Hello everybody, this is the second part of the section 4.5, which is the chain rule. But today we are going to use the chain rule and apply it to the implicit differentiations. Actually, you guys have learned the implicit differentiation before in calculus 1. But today we are going to elevate ourselves a little bit by looking at the z is an implicit function defined uh, in terms of x and y, okay, and as we define it implicit like this, your z and x and y will relate in one relation called capital F. For example, it may be saying that x squared plus y cubed plus z to the fifth equals to 10, okay, and your z is a function of x and y defined implicit by this relation. So it means that your capital F of x, y, z, it is x squared plus y cubed plus z fifth minus 10 equals to 0. Okay, so this simply your F. Okay, actually in this material later on they'll give you a formula to find the dz by dx. However, the way we teach, we are not going to use the formula, but we just going to use the chain rule. And then for example, if we want to find a derivative with respect to x, we are going to take a derivative with respect to x both sides, okay, and because the right hand side always equals to, usually we can move it anything around, or even is not zero. Right now just pretend that the right hand side is the 0 always first, okay, so you are going to get your right hand side as 0, okay, after you find a derivative with respect to x, okay. However, on your left hand side, because the derivative will take to the function capital F, and your f right now is a function of x, y, z, but your z still depends on x and y. So if you want to find a derivative with respect to x, you are going to have two contributions, okay. The first contribution is the one that you go to your x directly through the f, and then the second contribution is the one that you go through the z. So it is a df by dz and dz by dx, okay. And then because they are equal, the left and the left hand side and the right hand side, they are equal to each other, so we got this equation, okay. However, what we really need to find right now is dz by dx. So if you solve for it, the dz by dx becomes a negative df by dx over df by dz, which is the same formula as what we have here. However, as we do the problem, we usually use this relation instead, and then we are going to figure out dz by dx by ourselves, okay, without using this kind of formula. So let us start by looking at this problem, the first one. You need to find dz by dx and dz by dy. Of course, even though they didn't tell you, but actually your z is a function of x and y and defined implicitly, okay, by this relation, okay. You may say that, hey, this relation, you got both left hand side and right hand side, and your right hand side is not 0. So if you want, you can move everything to the left hand side and then let your right hand side to be 0, or you can just leave it like this. So to find dz by dx, you start from taking d by dx both sides, okay, and then don't forget that right now the real variable is only x and y, okay. The real variable is only x and y. So if you are going to find d by dx, it means that we regard your y as a constant, okay. Regard your y as a constant. However, all the z here has x hidden. Okay, actually it has x and y, but right now because you are taking derivative with respect to x, so all the z has your x hidden. So first let me just take a derivative to each term so that you can see it more clearly, just like that, because you got 3 terms, okay, for the left hand side, and then your right hand side you got a derivative with respect to x of 4x z minus a derivative with respect to x of 4yz, and then of course a derivative of 1. Okay, so the first one is easy, right? The derivative of x cubed with respect to x, so you got 3x squared. This one because right now your x is a variable, your y is a constant, you got a 0. And this one because your x is hidden in z, so you use the chain rule to have your these 3z squared, and then a derivative of the inside, which is dz by dx. And then this one you need to look at it carefully. Of course the 4 is a constant, so you can take it out. Your z, as we told, that got the x hidden in it, so this one is actually a function of x multiplied with a function of x, so you really need to use the product rule. So this is the first derivative of the second, which we don't know, right, because we don't really know the z function, plus the second derivative of the first, which is derivative of x, we got 1. And then because now your variable is x alone and your y is regarded as a constant, and I'm sorry, this is minus, so your 4y can pull out and the derivative apply to the z directly, and the last one, a derivative of 1, of course it is 0. So what is it that you guys need? You need to find dz by dx, right? So it's right here, one of them. It's right there, another one of them, and it's right over there. Okay, so you got 3 term that is depends on your dz by dx. So you just combine them together. So the first one you have 3x squared. The second one, don't forget you got 4x, but because it on the right hand side, so you move it to a negative. And the last one you have a minus 4y, so it becomes a plus. And then the rest you just kicked out to the right hand side. The first one you have 4z, you see, 4z, and then 0, and then don't forget this term, which is negative 3x squared. Okay, so it means that all what you need is your dz by dx. It is 4z minus 3x squared over 3z squared minus 4x and 4y. Okay, so this is a derivative of z with respect to x using the implicit differentiation. Okay, but if you guys say that, hey, it'll be a lot easier if we use a formula, go ahead and use it. We are not we don't have any obligation on using formula. Okay, but what we presented here, just using the understanding and the knowledge of a chain rule, that will be good enough, and you don't need to memorize anything too much. Okay, so let us find the second one, the dz by dy. So let me just copy the relation here. You got x cubed, you got y cubed, you got z cubed equals to 4xz minus 4yz, and then plus 1. And you want to find dz by dy. So all what you do is taking your d by dy both sides. Okay, so the first term becomes d by dy x cubed, d by dy y cubed, and d by dy z cubed equals to, on this right hand side, dy dy 4xz, d by dy 4yz, and then d by dy of 1. Okay, and don't forget that your z here and there have your y hidden. Okay, right now we concentrate on y because the derivative that we want is the one with respect to y. All right, so here, because your y is a variable, now your x is a constant, so it is 0. This one is easy, you got 3y squared, and this one, because your y is hidden in, so you got 3z squared, right? And then a chain rule, a derivative of the inside, which is dz by dy. Here your 4x is a constant, so you pull it out, and then the derivative, just go ahead and apply to the z. But this one, you have your y here, you have your y there hidden, so it is 2 function of y multiply. Okay, so you can pull out the 4, and the first derivative of the second plus the second derivative of the first, which is derivative of y with respect to y, and then the last one, of course, is just a constant, right? So again, you got this dy, dz by dy, dz by dy, and that dz by dy, 3 terms. So you just combine them together. The first one is 3z squared minus 4x, you see, and then plus 4y, you see, this one, equals to, what you have left is this one, the negative 4z, and then this term, negative 3y squared. So your dz by dy is just simply negative 4z minus 3y squared over 3z squared minus 4x and 4y. Okay, so if you use this idea to find your partial derivative, okay, from the implicit definition of your function, okay, that will be, I mean, to me, it will be a lot easier than memorize the formula, because if you want to memorize the formula, you need to have this extra negative over there, okay, so that you cannot forget. Okay, so let's look at the next example. Okay, actually we got 4 examples together. All right, so let's look at 2.1. You want to find a derivative with respect to x and with respect to y, right? So let us take the derivative with respect to x both sides first. So you have d by dx of x squared, d by dx of y squared, d by dx of z squared. So it's pretty much the same, and d by dx of 3xyz. Okay, it's look like the previous example that we just did. And don't forget that right now your z is a function of x and y, okay, defined implicitly. All right, so this means that your z right here has x and y hidden, but in the first context it has x hidden in it. So here the first term, I mean the derivative with respect to x, you got 2x, and your y is regarded to be a constant. Your z right here also has x hidden, so you got 2z and then a derivative of the inside with respect to x. Now your 3 and your y, they are constant, and then your x here and your z, I mean it's already 2 function of x multiply, so you use a product rule, the first derivative of the second plus the second derivative of the first, which is 1. So your dz by dx, okay, you got 2z, you got this one 3xy, equals to here 3yz minus 2x. So if you want this one alone, you just go ahead and divide it by 2z minus 3xy. Okay, so this one is your dz by dx. Let's try dz by dy. So you are going to take your d by dy both sides. So the first term is d by dy of x squared, d by dy of y squared, d by dy of z squared equals to d by dy of 3xyz. Okay, so now your z in this context has y hidden. Okay, so here the first one, because you got a y, so your x is a constant, and the second one you simply got 2y. The third one, because it is a z, so you got dz, and then 2z dz by dy equals your x is a constant, so you put it out, and then there is a y and a function of y, so you have the first derivative of the second plus the second derivative of the first, and then you combine the terms, so dz by dy with 2z minus 3xy, okay, and equals to z minus 2y. So it means that if you want that dy by dz, dz by dy alone, you just divide this right hand side by dz minus 3xy. Okay, that's pretty much easy, just like this. So this is the problem 2.1. Okay, so let us copy the 2.2 for you here, which is x minus y equals arctangent of yz. Okay, so to find derivative with respect to x, so first you take a derivative of with respect to x both sides, so the first term and then the second term and the right hand side. Okay, and remind yourself that your set here got x hidden, okay, in this context. So the first one, derivative of x with respect to x is 1. Here is a constant. And then derivative with respect to x, because here you still have the z there, so the arctangent is 1 over 1 plus yz square, and then a derivative of the inside. Okay, but because your y is a constant, then you can pull it out, and the derivative just go ahead to the z alone. So on your left hand side you got a 1, on your right hand side you got this one, and then a y and dz by dx. So if you need this one, then dz by dx is simply 1 plus y square z square over y. Okay, so on the other hand, if you need derivative with respect to y, so you take it, so you got d by dy of the first term x, d by dy of the second term which is y, and d by dy of the arctangent of yz. Okay, and you need to remind yourself that here in this context your z has the y hidden. Okay, so here the x regarded to be a constant, y is a variable, and then this arctangent becomes 1 over 1 plus y square z square, and then a derivative of the inside with respect to y. But here again, as we told you that this one has y hidden, so this function, I mean these two things is two function of y multiply. So you really need to use the product rule, which is the first derivative of the second plus the second derivative of the first, which is 1. Okay, so if you need to solve for dz by dy, then your dz by dy together with y over 1 plus y square z square z equals to, so this one, don't forget that you still need to distribute. So you have negative 1 over negative z, I mean negative 1 minus negative z over 1 plus y square z square. So if you need this one alone, you just go ahead and do the cross multiply, right? So this one becomes cross multiply with 1 plus y square z square over y. Okay, and you don't really need to simplify anything. This can be your final answer. Are we good? This is your second problem, 2.2. Okay, so now let's go to 2.3. Let us copy it down first. So you got I'm sorry, this is a typo. Okay, so I'll just write down the a good thing. So it is a side of x multiply y multiply z equals to the right hand side is x 2y and 3z. So if you want to find d by dx, so you take it both sides. So your left hand side and your right hand side contain 3 terms. Oh, sorry, it is a d by dx, sorry, 2y and then d by dx of 3z. Okay, but now your z has x in there. Okay, your z has x hidden in there. Look at your right hand side, a derivative of sine, it is a cosine, right? And then you need to find a derivative of the angle inside. This one is 1, this one is a constant, so it's 0. This one has x hidden, so it is dz by dx. So here your y is a constant, so you can pull it out, but again your x is a function of x, your z is also a function of x, so it is a product, right? So your y you usually put out there, and the product, let me just write down first. So it's the first derivative of the second plus the second derivative of the first, and don't forget the cosine that we need to copy it down. This is 1 and 3 dz by dx. So here is what you need. So you combine them together, so the dz by dx. On this one, you not only have the x and y, but you also have a cosine. And then this one you got a 3, and you just dump everything else to the right hand side. So you have this one as well, yz and cosine xyz. Okay, so to find only this one, you just move this one to the right hand side, get it to be a fraction. Okay, we good? So this is the derivative with respect to x. Next, if we want to find a derivative with respect to y, so you are going to take a d by dy both sides. So it is a first term on the right, the second term on the right, and the third term on the right. Again, this one has y in there, this one has y in there. So if you want to find this derivative, you got a cosine x, y, z, and then a derivative with respect to y of the function inside. This is a constant, this one is a 2, and this one is a 3, and a derivative of z with respect to y. So again, here you have y, there you have a function of y, so you need to use a product rule. So let me just write down first. So the x is pulled out, and then the first derivative of the second plus the second derivative of the first, and then don't forget your cosine to copy it down, equals to 2 plus 3 dz by dy, and solve for this. So your dz by dy, the first term you have xy cosine xyz minus 3 equals to 2 minus this one xz cosine xyz. Okay, so you just do the same thing. Okay, all what you need is to move this factor to the right hand side as a bottom, okay, as a fraction like this. Okay, so this is your 2.3. okay, 2.3. All right, so let us look at the last problem, 2.4. It is yz equals to log of x plus z. Okay, so to find a derivative with respect to x, so you take it both sides, just like that. Here you got x hidden, there you got x hidden. So it means that for the first one, your y is a constant, so you just pull it out, and a derivative go directly to the z. A derivative of the log is 1 over, and then a derivative of the inside, which is 1, and dz by dx. So it means that your dz by dx depends on y minus this one, right? 1 over x plus z, and then equals to 1 over x plus z. So to solve for this one, you just move this way around and then make a fraction. Okay, just move this one to make a bottom of your fractions. All right, and if you want to find d by dy, it is a d by dy of yz equals d by dy of log of x plus z. So your z has y hidden, okay, in there. So this one you need to use a product. So it is the first derivative of the second and the second derivative of the first, and this one, the log is 1 over x plus z, and a derivative of the inside, x is 0, and dz by dy. So again, you have 2 dz by dy, so you combine them together. But then this one you got the negative z alone, so you just move it there. It means that your dz by dy is simply negative z over y minus 1 over x plus z. And you don't really need to simplify all that fractions, okay? Just leave it like that. That will be the best final answer that we're looking for. Okay, so this is the implicit derivative, and we do it using or the chain rule only, okay, without any formula. Okay, but if you like to remember formula, you can just use a formula and apply it. That will be that will give you the same answer as well. Okay, so we are going to stop this section right here. Okay, so now we finish section 4.5, and then you guys will continue with some other section in chapter 4. We'll see you then. Bye bye.